Good afternoon. In our last class, we talked about combination, permutation, and we talked about permutation involving arrangement of letters of alphabets. Permutation involving arrangement of letters of alphabets. But today we'll be talking about permutation involving straight line arrangements. Permutation involving straight line arrangements. Involving straight line arrangements. So, the number of ways of arranging n objects on a straight line is given by n factorial. The number of ways of arranging n objects on a straight line is given by n factorial. For example, in how many ways can 5 persons sit? Can 5 persons be seated on a bench? A principal, his wife, and 3 other tutors, are to be seated on a bench. Find the number of ways this can be done. If A, no restriction, B, the principal and his wife insisted sitting next to each other. So we have solutions. Number 1, in how many ways can 5 persons be seated on a bench? So for 5 persons, n is equals to 5. For 5 persons, n is equals to 5. Therefore, the number of ways become 5 factorial. The number of ways becomes 5 factorial. So here is 5 times 4 times 3 times 2 times 1. So 5 times 4 is 20, 60, 120. So 120 ways. Then number 2, in how many ways a principal, his wife, and 3 other tutors are to be seated on a bench? Find the number of ways this can be done if no restriction, if there is no condition So if there is no condition, the total number of persons, n is equals to 5. For no restriction, the number of ways equals to n factorial, which is 5 factorial, which is equals to 120 ways. Then B, if the principal and his wife insisted sitting next to each other. If the principal and his wife insist sitting next to each other. If two or more persons insist sitting together, comma, they should not be counted. They should be taken as one. They should be taken as one, and then be added to the remaining. That is, we have 4 factorial. Now, the reason why it is 4 factorial, if the principal and his wife insist sitting next to each other, the principal and his wife will be taken as one, and they will now be added to the 3 other tutors. So the total number becomes 4. So it is 4 factorial, which is 4 times 3 times 2 times 1. So it's 24 ways. It's 24 ways. So now I want to look at permutation involving cyclic arrangements. Permutation involving cyclic arrangements. If n objects are arranged in a cyclic manner, comma, the number of ways of permuting them is n minus 1 factorial. If n objects are arranged in a cyclic manner, the number of ways of permuting them is n minus 1 factorial. For instance, find the number of ways in which 4 persons can sit round a table. Then 2, find the number of ways in which 2 boys and 3 girls can sit round a table. So let's look at these two solutions. Now, for the first one, find the number of ways in which 4 persons can sit around a table. So for 4 persons, comma, n is equals to 4. For 4 persons, n is equals to 4. So therefore, the number of ways is equal to n minus 1 factorial, which is equals to 4 minus 1 factorial. So we have 3 factorial. So here is equals to 3 times 2 times 1, which is 6 ways. So for the last example, for 2 boys and 3 girls, comma, n is equals to 2 plus 3, which is 5. So the number of ways is equals to n minus 1 factorial. So which is 5 minus 1 factorial, which is 4 factorial. So here is 4 times 3 times 2 times 1. So here it becomes 24 ways. So we are going to look at the last aspect of this video. So we'll be talking about permutation involving arrangement of arrow objects arrangement of objects. To arrange arrow objects from a total of n objects, we use n permutation arrow equal to n factorial n minus arrow factorial. So we'll take example. In how many ways can 3 books be arranged in 10 shelves? In how many ways can 3 books be arranged in 10 shelves? So solution: for 3 books, comma, arrow equals to 3, and 10 shelves, n equals to 10. Therefore, the number of ways equal to n permutation arrow, which is equals to 10 permutation 3. So if you remember the formula of permutation, n permutation arrow equals to n factorial over n minus arrow factorial. So if we have 10 permutation 3, this is 10 factorial over 10 minus 3 factorial. So here is 10 factorial over 7 factorial. So we have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 times 6 times 5 times 4 times 3 times 2 times 1. So we can cancel. So our answer becomes 720 ways. But the shorter way, in our last video, the shorter way of solving 10 factorial over 7 factorial, the shorter way of solving 10 factorial over 7 factorial is to multiply 10 to 7 factorial. So which is 10 times 9 times 8 times 7 factorial over 7 factorial. So 7 factorial cancel 7 factorial. 10 times 9 times 8. So 720 ways. So thank you very much for this.